Okay, so first one, we need to draw this function, x squared minus 1. So this is functions. So the first question we need to draw is draw the functions x squared minus 1, 4x minus 2, and minus x over 2 minus 2 on a common set of axes. Okay, so let's get some axes out for us. We'll zoom out. Okay, so we want x squared minus 1. So x squared minus 1 is a happy face, but minus 1. Okay, so we'll make that half a box, and it will just be a simple happy face like that. Okay, that would be y equals x squared minus 1. So it's a positive quadratic happy face. The minus 1 represents the y-intercept here, which will be minus 1. Okay, the next one is 4x minus 2. The gradient is 4. The y-intercept is minus 2. So minus 2. And the gradient is 4. Okay. However, we should probably get the intersection points of here just to know whether it will go like that or whether it will skip this graph entirely. So I guess B helps us with this sketch. It will intersect the x-axis. So if we have y equals to 4x minus 2, then when y equals to 0, we will get x equals to 2 over 4, which is a half. Okay. Now, when does x squared minus 1 equal to 0? It will equal to 0 when x equals to plus or minus 1. Okay, once you move the 1 to the other side, then square root. So that will be 1, that will be minus 1. So this line does indeed cross this line here and here. Okay, so I'll draw that again just because that was very well drawn. So that would be this one, which is y equals to 4x minus 2. So we have those 2 points now, and then the next one is minus x over 2 minus 2. Okay, so that's minus 2 again, and we want a gradient of minus half. Okay, so minus a half, if you want to get the x-intercept of that, will be minus x over 2 minus 2 equals 0. Minus x over 2 plus the 2, so the other side will equal to 2. X minus x will equal to 4. You move the 2 to the other side, x will equal to minus 4. So that won't hit here until minus 4. Okay, and that would be something like that. Okay, I'll try to do that slightly better. So it would look like that. Yeah? And then this would be y equals to minus x over 2 minus 2. Work out the x values of the intersection points of these three functions. Okay, so that is fairly involved. The first one is quite easy. These two intersect at minus 2. Yeah, so let me label them as y1, y2, and y3. So this one is y1, this one is y2, this one is y3. Okay, so clearly y2 and y3 intersect at minus 2. Yeah, let me just create some space for ourselves. So y2 and y3 intersect at 0, minus 2. So that one was done for us. However, y3 doesn't intersect with y1. So that one is done. We just need the intersection of y1 and y2. Okay, y1 and y2. So that is going to be x squared minus 1 equals to 4x minus 2 for that intersection point. And we can move everything to the same side. So that will become x squared minus 4x plus 2, that will be plus 1. Okay, equals to 0. Plus 1. Okay. Now we need to solve this. You can quite clearly see no two numbers times together to make 1 and add to make -4. We can probably do completing the square quickly or the quadratic formula. Let's just make sure we haven't made any mistakes, as is good practice. Because normally in PAT they give you something which can factorize. So it's a quadratic formula, so we can just use that quickly. So it will be minus b plus or minus square b squared minus 4ac over 2a. Okay, so that would be 4, because minus minus 4, plus or minus square root 4 squared minus 4ac is 1, 1. Okay, 1 times 1, so that's just 1, over 2 times 1, which is 2 times 1. Okay, now that will equal to, if I show you, I'm just typing this in my calculator as I speak, just to confirm. We give us 2 plus root 3. Okay, 2 plus root 3, and I suppose it will be 2 minus root 3, because that would just become a negative sign. So 2 plus or minus root 3 is the x coordinates. Okay, so x1, the first coordinate will be 2 plus root 3, and then the y value will be 4 times that, and then minus 2. Yeah, because we know that y equals to 4x minus 2. So that would be 4 times a 2 plus root 3 minus 2. Should give us 6 plus 4 root 3. Or the other solution would be 2 minus root 3 there. Okay, that would be 6 minus 4 root 3. Now, for this question, we should check. So clearly, yep, one is below the axis and one is above the axis. So those are the two solutions. So that was part B, done. And then part C is write down a single integral which just describes a finite area bounded by the 2 of the 3 functions. So clearly that is this area, because 2 of the 3 functions cause this area here. Now that area is going to be the integral. Because the green one is above, we're going to minus the integral of the one under y2 from the integral of the one under the the curve. Okay. Okay, so let's resume this question now. So we want the single integral. So the single integral is going to be, we know that the x value here is going to be, what did we get as a solution again? 2 plus or minus root 3. So this one will be 2 minus root 3, and that one there will be 2 plus root 3. Okay, so to get the integral, minus the integral of the one below between the two intersection points. So to find the area of the enclosed section, so it would be 2 plus root 3, the x coordinate there, to 2 minus root 3, the x coordinate there, and then it will be 4x minus 2, and then minus the x squared minus 1. Okay, and then that would give us, of course, dx for all integrals. So that would be 2 plus root 3, 2 minus root 3, 4x minus 2 minus x squared minus 1. So that would be minus x squared plus 4x minus 2 minus minus 1 would give us minus 1. Okay, and the dx. Okay, so let's look at sketching functions a bit more. So this is x squared plus 2x minus 7. Okay, so we have y equals to x squared plus 2x minus 7. Now, what we need to do to sketch it is that this is the y-intercept, because for a quadratic, the bit without the x is always the y-intercept. This number is positive, so it's a positive quadratic, makes it a happy face. And we could get the y at the intersects of the x-axis, but it says we are not required to determine coordinates of the intersections with the x or y values. So I think we can just do a rough sketch like that, and it should be fine. But I'm sure you probably know how to find the intersects with the x-axis by setting it equal to 0. So we intersect with the y-axis at -7, and we simply have a happy face. Okay. Perhaps it would help to get the intersects, but it would take a little longer. At least we can get the minimum point. So if we were to write this as completing the square, it will become x plus 1 squared, -1 and -7, which will become -8. Okay, and that means that the minimum will be -1, -8. So the minimum would be around there. At least that will help us get a better shape of the graph. Okay, and then this one is gx, which is 2 over x. Now 2 over x is a reciprocal graph. You should just remember it, that it will simply look like that, okay? Because that's the way reciprocal graphs look. The 2 is a transformation which will just bring it more outwards, but because we're just drawing a sketch, it will just look the same. We could draw it identically because we are not taking into account the exact coordinates, okay? We're just drawing a quick sketch. Now, the points of intersection are when these two functions are equal. So that is another part of this question. So that would be 2 over x equals to x squared plus 2x minus 7. So we want to times everything by x. So that would give us 2 equals to x cubed plus 2x squared minus 7x. We want to set that equal to 0 to solve this. So x cubed plus 2x squared minus 7x minus 2 equals to 0. And from here, this is a quadratic equation that we need to solve, okay? So solving a cubic is actually something maybe we can use a function theory to help us. So clearly we can see from the intersection points that x equals 0 is not a solution, but we can maybe try guess for this solution. We can try x equals 1, x equals 2. So let's try if x equals to 1, is that a solution? So if you type that into the calculator, typing in 1 cubed plus 2 minus 7 minus 7 minus 2. So that would be 3 minus 7, which is minus 4 minus 2 minus 6. So that's not a solution. We can try x equals to 2. So then that would be 2 cubed plus 2 times 4, which is 8, minus 14 minus 2. So 8 plus 8 minus 14 minus 2 is 0. So that is a solution. So now we know that is x minus 2 times a function ax squared plus bx plus c is going to give us, we need to find a, b, and c to factorize this. Now clearly c we need to equal to 1 because minus 2 times the c should give us the minus 2. Just to show you this fully, we can expand this out. So times it all by the x. So that would be ax cubed plus bx squared and then plus the cx. You could alternatively divide this function by the x minus 2 to get it. This is just another method of doing it. Minus 2ax squared minus 2bx minus 2c equals to 0. So the minus 2c should equal to, that should, all the parts here should line up. So ax cubed and then bx squared, if you should be b minus 2a. for the x squared, okay? And for the x, it should be c minus 2b x and minus 2c equals to 0. And we know that we have the function like this. Minus 7x minus 2 equals to 0. So from here, it should be quite straightforward. You can draw an analogy. So here you can see a is equal to 1, c is equal to minus 2. And we have, actually, no, that is not correct. Minus 2c equals to minus 2. So c is equal to 1. And then here, you got c minus 2b or b minus 2a. So let's do this one. B minus 2a equals to 2. Those coefficients must align. So b equals to 2 plus 2a, which is 4. And then we got c minus 2b equals to minus 7. So that would be 1 minus 8 equals to minus 7. So that's just confirmational. So we got a, when I say confirmational, I mean, we're just confirming that. We haven't found anything with that, but the fact that it lines up is a good sign. So we factorized it now. The cubic to be x minus 2, and we know a is 1 there. We know b is 4, and we know c is 1, okay? So that will equal to 0, and this one we can try get the solutions. So that will be x equals to 2. This one, the solutions we can get by doing completing the square. So that would be x plus 2 squared if we complete the square, minus 4 plus 1 equals to 0. So that would be x plus 2 squared. That would be minus 3 there. So x will equal to plus or minus root 3 minus 2. Yeah? Because we have to square root both sides. Plus or minus when you square root minus the 2. Okay, so that is the solutions, 3 solutions for the intersection. However, we want the y intersections as well, which will come from the other equation, which is 2 over x. That's an easier one to use. So the y coordinate, which corresponds to this, will be 2 over the x, which will be 1. And over here, the y will equal to 2 over x. So it will be 2 over either root 3 minus 2 or 2 over minus root 3 minus 2. You could rationalize the denominators, type that in a calculator, and get a more simpler answer, but that is the answer. Okay? Great. The next question is asking us to do the integral. We're going to cover integration in another part. I know I did cover it briefly here, but I'd leave that for that part of the course, okay? The next part is telling us if fx, this next question 24 of the same paper, fx is defined by this triangular function, and gx is the reverse of this function. It wants us to sketch x minus ct plus gx plus ct, or t equals to a over 2c, 3a over 4c, and a over c. And want to do each one separately, okay? So let's do it first for t equals to a over 2c, okay? So fx minus ct will be fx minus the c times by a over 2c, which will be fx minus a over 2. Okay, so that one, we just want to move it. This minus ct means move ct to the right. Okay, but let's do the gx. Now, luckily, or fortunately, they don't intersect here, but once they move, they might. Okay, so we need to think about each of them separately and then how they superimpose. So let's do that first. So fx minus 2 is just a to the 2 to the right, a over 2 to the right, I should say. So let's put that down here for us. So that will move a over 2 to the right, okay? So half a t, half a that way. So it will just look like that, okay? And that will be minus a over 2 and a over 2. And the next one will be gx plus ct. So that would be gx plus a over 2, okay? So gx plus a over 2, because we know ct now is just a over 2. So I can just simply write that. I'll take a screenshot of this function and see how that moves. So plus a over 2 means we move to the left by a over 2, okay? So that is going to become here a over 2 because we're moving to the left. Sorry, 3a over 2, and that will be a over 2. So it will be simply like that. Okay. Now, this one I realized that should actually be minus 3a over 2. Yeah. So apologies for that. Change that. Okay, so that's that. And a over 2, 3a over 2. And we've got this new, and now we need to add them, okay? So the key point to think about is how are all these points adding up, okay? So they are adding up. Let's look at this one. So minus 3a over 2. This point here is minus a over 2. So we need to look at these two functions and see how they line up. So minus 3 over 2 until minus a over 2, nothing's affected us from this function because until there. So from there, we just can keep that as it was, okay? Until this point to minus a over 2. However, from minus a over 2, now we drop down with both of them. So until a over 2, we're dropping down by minus a with this function. So think about the sum of both of them. So at minus a over 2, we're adding a with 0, okay? And then at the end, we're adding 0 with minus a. Okay, so that means we're going to go from 0a all the way to minus 2a. Now let's look at the 0 point will be over here from a over 2 minus a over 2 will be 0. So we'll just reach all the way there to minus a, okay? And that will also be a over 2. And then from a over 2, we can get rid of this function and we're just going to go to 0 until 3a over 2. Okay, so it would look like that. Okay, so the next part now is asking us for 3a over 4c. Okay, so 3a over 4c. So we want fx, what was it, plus ct or minus ct? Okay, minus ct. 3a over 4c. So that would just be fx minus 3a over 4, isn't it? The c's just cancel out. So we're going to move 3/4 of a to the right for this function, okay? Because that was the fx. Okay, so we're going to move 3/4 of a to the right. So this point here will be minus 5a over 4 minus a over 4. And this point will be 3a over 4. We are moving exactly 3 spaces to the right, 3a over 4 to the right. The next one will be gx plus 3 over 4. So I know this seems quite a long question. It is. However, once we do one part of it, it should become repetitive. You can start to see patterns. So this one, we're going to move 3 over 4a to the left, okay? So then that's going to be 5a over 4, a over 4 minus 3 over 4, okay? Like that. I will try to fix that. So that should definitely be there. Okay, so now we're going to have to try combine these two functions. Now, you should try to see a pattern between this one and the previous one. The last one, you saw I had to slow down and explain it very slowly, and hopefully if that made sense, it should help, okay? So the new one starts from minus 3a over 4, and we are either going to a or we're going down to minus a. So those two are going to cancel each other out, okay? So from minus 3 over 4 to a over 4, we're just going to cancel each other out. We're going to stay at the 0 line. And then at a over 4, we've reached our maximum here, a, and we've reached our minimum here, and we're both going to go to 0. So we're going to go from 0 to 0, and we're going to cancel each other out. So the two functions actually cancel each other out completely until a value. So interestingly, this one will go to 5a over 4, but this one only goes to 3a over 4. Okay, so I realized I messed up. Okay, so from minus 3 over 4 until a over 4, we are reaching our maximum here. Okay, so from minus 5a over 4 until minus 3 over 4, we are just rising, okay? From minus 5a over 4 to minus 3a over 4, we are simply just going to be rising as you do there. And that is half a over 2. So in a period of a, we go up a. So that would be a over 2. Now, the next point over here, which is from minus 3a over 4, we drop down 3 quarters a. So that would be 3 quarters a minus 3 quarters a, and that will be plus 3 quarters a. So we reach 0 until that point. Okay, and then from this end point, which is 3a over 4, at 3a over 4, we will be at 0 on this function, okay? But on this function at 3a over 4, we would have done half a over 2. So that will also be a over 2 again, okay? But it will be negative a over 2. So that will be negative a over 2. And that point there will be 3a over 4. Okay, and then from that point to 5a over 4, where we reach there, we reach 0, okay, until 5a over 4. Okay, now finally, let's look at the situation where t equals to a over c. So fx minus ct will be fx minus c times t. I mean, the c cancels out, so it'll just be fx minus a. Okay, and gx plus ct will just be gx plus a. Okay, so let's put that here again. Okay, so the fx, whoops, that's not the one I want. We want this one. So let's put that here, okay? Now, this means we move a to the right, okay? All our points just move a to the right, so fairly straightforward. Now, gx, I'm actually going to do on the same graph. I think it might help. So gx was originally looking like that until 2a and a. And then we look at it in green, okay? So we're going to move a to the left from here. So it would simply be like that, you're moving a to the left. Now, these functions actually cancel out because the amount we go up is the amount we go down. The amount we go up here is the amount we go down. So at any point, it will be minus a plus a0, a minus a0, a0. So the sum of them, so just to clarify, this was the x minus a, this was the gx plus a, and then to get the sum, it will just be a flat line going over it. Okay, well, that's it.